Hi everybody. Today we will be looking at the a Criterion B investigation. We'll be looking at the solutions of a pattern work, and today we'll be looking at how we could unlock a Criterion B investigation, uh, making general rules, and we'll be looking at some of the big command terms that we use in the Criterion B assessment. And hopefully you'll find this video helpful for you to revise your Criterion B assessments. I think in general, Criterion B assessments have always been quite tricky for students, um, as the investigations can vary in different forms and in different difficulty levels as well. So I thought that I would like to spend a bit of time to look at this investigation, and hopefully this is going to help you to improve in terms of your literacy skills, as well as formulating general rules as well from this investigation. All right, so let's look at the context of this problem. So we do have a parabola here. We do have a line segment of AB, which is part of the line y equal to 1. So I'll just be clear about what is y equal to 1. So y equal to 1 basically would be this horizontal line. This is basically y equal to 1. And you realize that the parabola actually meets the line y equal to 1 at 2 points, which is at A and B. Okay, so basically, usually in Criterion B investigation, there's always going to be a lot of hints. There's going to be a lot of information that you need to process before you start generating or finding patterns and making general rules thereafter. Okay, so please make sure you read the question. It's so important to pick out the key information from an investigation. Okay, so let's just move on, and it says write down the length of the line segment AB. So if we're going to find the length, I'm sure we can count the length. I'm just going to make this a bit bigger. So if we look at the x-coordinate, it falls at -1. The x-coordinate here is 1. So if we find the difference between 1 and -1, that's going to be 2, isn't it? So the length of the line segment is just going to be 2 units. So we can actually just infer from the diagram above. Now let's move on. And now we have more images. So this is basically what it's the same graph, but they put this graph under stage n equal to 1. Okay, so it's probably going to show a couple of stages with different graphs, and probably you should be able to see some patterns from there. So let's look at stage 2. You kind of realize that it's a very similar graph, but you realize that the length of the line doesn't cut at y equal to 1. It now cuts at y equal to 3. And this is stage 3. All right, so the line kind of went up again. The line segment gets longer, but it cuts at the line y equal to 5. And stage n equal to 4, where the line cuts at y equal to 7. So I think we know where this is all coming from. Trying to spot a pattern here. So it says that show that when n equal to 2, the length of the line segment is 2√3. Now the keyword is show. So you have to kind of show some mathematical workings that's needed for us to get 2√3. Okay, so let's go back to stage equal to n equal to 2. And our job is to find out why is this length 2√3. So we're going to use the same methodology from stage 1. What we need to do is we need to find out what is this point, this coordinate for x, and as well as this. Now this is not very clear cut because it doesn't give us like a whole number or an integer. So generally we need to work out how we could find these two x coordinates here. Okay, now we do know that the line segment meets at y equal to 3, and we have an equation of the parabola here, which is y equal to x squared. So I think it kind of makes sense that since we know that the line segment cuts at the parabola at y equal to 3, then it just kind of makes logical sense to substitute the value of y equal to 3 into the equation. Okay, so I'm going to show this how this could be done. So we have x squared equal to 3. Now we know that x is basically taking the square root of 3, but not forgetting that this will also include a negative value, because we know that negative root 3 times negative root 3 would also give me 3. So we do have to consider both the positive and the negative answer as well, which kind of makes sense from a graphical perspective, because we need two x coordinates, isn't it? So in general, let's go back to the graph here. We know that this point is actually going to be root 3, and this point is going to be negative root 3. So if we want to find the distance between these 2 points, we can just subtract both values together, and this should give me root 3 plus root 3, which gives me 2 root 3. Okay? For those who are not comfortable with surds, you could basically consider this as like x plus x. We know is 2x, isn't it, from our basic principles of algebra. So root 3 plus root 3 is pretty much the same thing. If you kind of replace root 3 with x, so x plus x is 2x, so root 3 plus root 3 automatically will also give you like 2 root 3. So for those who are not very familiar with surds, this is what we could do when we add up two surds together. Okay, so all right, so I think we have just done question 1.2. Then we're going to start moving on to fill out the missing values in the table. So obviously we found in stage 1, this was 2. The rest were given. Now stage 5 and 6, even though it was in the table, but it's not given us the length of AB. But if you kind of realize that, is that the numbers under the surds or the square roots seems to follow a pattern here. We know that these numbers are basically going up by 2 each time. Okay, so we do know that the next one will be just 2 root 9. And the next one obviously is going to be 2 root 11. Okay, just by following the pattern that we see here. All right, and now we're going to start looking at describing the pattern. Again, the keyword is describe, which means you have to write this in words, okay? And I mean, the definition of describe is to give a detailed account of a process, a situation, and an event. But in this case, in layman terms, what we're looking at is just give me details, all right? And you need to write this in words as well, okay? So, so when it comes to describing the pattern, I think what students really struggle with is that because we know that the only thing that have changed is the numbers in the square root sign or under the surd, and they kind of find it very hard to write this in words. So one way is when we write the pattern, we could say that that AB kind of follows the pattern so that it equals, the pattern is such, it equals for each state number, it equals to 2 times the square root. So I'm basically trying to describe how each of these numbers actually look like. Okay, 2 times the square root of the nth odd number. Okay, because for stage 1, even though it doesn't have a square root, but we can always write this as 2 square root 1, because square root of 1 is basically 1, and if we take 2 times 1, that still gives me 2. So this can be written as 2 square root 1. So it kind of just like aligns with the pattern that we see in the other stages in this case. And if you realize that 1, 3, 5, 7, 9, 11 in the square root sign, they are all odd numbers. So we can actually write odd number in the pattern here. Okay, so of course, there are many other answers that you could be writing. You could be saying something like, as the stage number goes up by 1, the number in the surd increases by 2 as well. I think that generally will be an acceptable answer. Okay, so this is just one way of writing the pattern, but there are obviously many alternatives to the answers for this. Okay, So the question next would be write down the general rule of L in terms of n. Okay, so we do know that if you look at the pattern in the table, is that we always have 2 multiplied by a third. Okay, and we know that the 2 has basically appeared in every stage number. So we know that the formula is going to involve a 2. Does that kind of make sense? So but we also know that in the numbers in the square root, so we have, like, for instance, square root 1, square root 3, square root 5, square root 7, square root 9. These numbers, all right, they do follow a sequence in it, which is 1, 3, 5, 7, 9. Okay, and this obviously would follow like a linear sequence or arithmetic sequence, and we can easily find a formula for that. Now, since the difference or the common difference between the numbers is always 2, all right, we can always start off the formula by having the formula to be 2n. But 2n, when you generate a set of numbers from 2n with the first term, second term, third term, and so on, is going to create values of 2, 4, 6, 8, and 10, which is basically multiples of 2. So we know that 2n is not the complete formula for that, but we do know that in order for us to get these numbers to the original set of numbers of 1, 3, 5, 7, 9, we will have to subtract 1, because if you subtract 2 by 1, it's going to give me the first number to be 1. So it's going to end up becoming 2n minus 1, which is going to give me 1, 3, 5, 7, and 9. Now, let's try to put everything together. So we know that the formula inside the third is going to be 1, 3, 5, 7, and 9. 2n minus 1. But not forgetting, we know that there's always a 2 that appears with the third as well. So what we need to do is, if we put everything together, and we need to write this in an equation form of L in terms of n. So it's going to be L equal to 2 square root 2n minus 1. Okay, so if you did not write like the L as part of your general rule, I don't think you're going to get full credit for this. Okay, so it is important for you to write the variables, write this in equation form. I think that's going to be helpful for you. Okay, we're going to start looking at verify. Again, the very typical command terms that we see in Criterion B, which is verify. Now, we're going to do this again one more time when it comes to verification. All right, I think it is important for you to sort out how to get maximum credit when you verify a general rule. The good thing about Criterion B is that if you are aiming to get like a 5 or 6, you're not required to come up with the correct general rule, but it needs to be consistent with the pattern that you found earlier from the table. All right, and which means that you still should be able to get some credit if you come up with a general rule that is consistent with the pattern that you found in the previous question. Even if the pattern is wrong, but if it's consistent, you will get some credit out of that as well. All right, so please, if you struggle with the pattern, don't give up. Make sure you keep going on, trying to write a general rule, and then you could verify it as well. Okay, now what I want to do is, which one should I use, or which stage number should I use to verify my general rule? Now, remember, 1 to 4 was given to you. So it kind of makes sense to do the next stage number, which is stage number 5. I will discourage you from choosing a large stage number just by the fact that it's just going to create more trouble for you as well. So always pick the next stage number that has been given to you, but the length in the table was not this close. So I think stage number 5 would be that appropriate one. All right, you could even do stage number 6 if you want to, but I think 5 is just a logical way of doing it. Since we have done all the way up to 4, 5 is the next one you want to do. So let's do when stage number 5, right? So when we n equal to 5, first thing, let's try to put this number into the formula. Okay, so you're going to get 2, 10 minus 1. That gives me 2 root 9. But that's still not good enough. Like, how do we know if this is actually right in the first place? All right, so we want to be sure by looking back at the table here. And we know that the pattern in the third was always adding 2 each time. All right, so it's like 3, 5, 7. So we know automatically the next one will be 9. So I would prefer Now, this is obviously the first way to verify it, the first method with the general rule. I would like you to come up with the second way. Now, the second method usually comes in the form of a table, or it could be a diagram, and it really comes down to the context of the problem. It really depends on what kind of information is given to you as well. So in this case, I think it's better to do the table, all right, because just by following the pattern, okay, when n equal to 5, your length is going to be taking stage number 4, which is 2 root 7. 2 root 7. Then I'm going to add 2 to this because we know that the number in this is basically going up by 2 each time, all right, in the third, all right? So that'll be 2 square root 9. And since both numbers match, so my rule is verified. Okay, I think this is a complete verification for that. And of course, it is helpful if you want to do another example. I think that's fine. But I think generally with one example, it should be good to go when it comes to and Criterion B assessment. But then again, every school does it very differently. E-assessment basically only requested for one example, but having 2 is always a good assurance for you as well. All right, good insurance for you. To check whether you have been on doing things the right track as well, okay, or if you're on the right path. All right, so let's look at the next part of this investigation. It says like they're drawing, so we were looking at the line segments earlier, but now they're drawing some perpendiculars to the line that creates like a rectangle here. So this is stage n equal to 1, and we do the same thing for stage n equal to 2 with the same line segment, which is at y equal to 3. And basically drawing 2 lines down to create a rectangle. And the same thing goes with stage n equal to 3 and stage n. We're going to do this investigation pretty much again, but in this case we're looking at the perimeter and the area of the rectangle. And again, since some table is given to us, and let's try to spot some pattern from this again. Right, I'm just going to put the brackets here. Right, this was missing. So we got the perimeter and the area of the rectangle that's given to us with the stage numbers as well. So again, if you were to see the pattern, I think it's quite obvious that the pattern looks quite similar to what we've done earlier. So this will be 2 root 9 plus 9, because again, it's going up by 2 each time. And this will be 2 root 11 plus 11, okay? And again, if we have the area of the rectangle, which is 2 times 3 to the power 3 over 2. Now, you might ask, like, this guy doesn't seem to look very similar to the other 3 cases in this case. Because if you realize 3, 5, 7 is going up by 2 each time. But the powers is always 3 over 2 as a fraction. So can we actually rewrite this? We could, we could write it something like 2 times 1 to the power of 3 over 2. Now, the good news is that 1 to the power of any number, all right, is always going to give me 1. I mean, you can try putting 1 to the power 3 over 2, that's going to give me 1. 1 to the power 6, that's also going to give me 1, whatsoever that is, okay? So again, if we write the pattern here, this will be 2 times 9 to the power 3 over 2. This will be 2 times 11 to the power 3 over 2, okay? Very, very straightforward pattern in this case, all right? So the next part, it says, predict more values. So we're done with this, we're done with this. Describe in words the pattern followed by the perimeter of the rectangle. Okay, so again, it's trying to describe that in words. So I'm going to write this here. We could say that the perimeter is 2 times the sum, right? Look at the numbers in the brackets of 2 times, I'm just basically writing this, all these in words, okay? The square root of n odd number, because the sum, right? We're talking about the sum of these 2 terms, and just simply the nth odd term. Okay? Again, because these two numbers are actually generally the same here. These two numbers are generally the same here. Okay? So I'm just basically writing this in words because the question asks for describing the pattern. Okay? So that will take care of this part. So this is done. The description is done. So it says write down the general rule of P in terms of N. So I'm going to make an attempt to write the general rule for P. Okay, so P is going to be 2, because every stage there's always 2 times a specific term. So we can always start off by writing 2 times. I'll put the brackets in. Then this will be 2 square root. Again, because the pattern is going up by 2 each time. So that's going to be the same thing as what we did earlier, which is 2n minus 1. Then you plus 2n minus 1 again. Now, remember this 3 here can also be written as 2 times, all right, let me just enlarge this a bit. This will be 2 times bracket 2 root 1 plus 1. Okay, because 2 times root 1 is actually just 2. And 2 plus 1 is actually just simply 3. So again, the pattern, it is consistent in this case. Okay, and remember 2n minus 1 is what we found earlier. And since the pattern works the same for the perimeter of the rectangle, then we can just use the answer that we had earlier. That will save you some time. Okay, now let's look at the area. Okay, so the area, we know that again it starts with 2 multiplied by, again it's 1, 3, 5, 7, 9, 11. So we know that there's going to be 2n minus 1. And since the power is always 3 over 2, then I'll just put 3 over 2 here. So very, very straightforward with these two general rules for this. Okay, so we're done with the next two. The next part, we're going to test and justify the general rule for A. Okay, so, but I'm going to do the testing first. Now, remember, if you do a testing of a general rule, we are supposed to use the values that's given to us in the table, which means that you could use stage 1, 2, 3, or 4. Any stage will be fine. Okay, you can just choose one of your own choice here. And since we're going to be testing the general rule for the area, so all we need to do is to test this area. So let's try when n equal to 2. The area is just 2 times 2 times 2 minus 1 to the power of 3 over 2. Okay, and this gives me 2 times 4 minus 1, which is 3 times 3 over 2. Now let's go back to the table and let's look at the area. It looks the same, isn't it? So we could just say that the value match with the table. The table value. Okay, so hence my rule is verified. So far so good. Okay, I'm just going to do one more verification here. I think I'm kind of running out of space, but that's all right. Because I'm going to erase that later for the justification part. Okay, so verify, very much the same thing, okay? So I think it's logical to do n equal to 5. That's the next stage that we should be doing. So when n equal to 5, the area is equal to 2 times 2 to the 5 minus 1 to the power 3 over 2. So that's actually 2 times 9 to the power 3 over 2. Okay? Which actually looks very much like this. Okay? But remember, when it comes to verification, make sure you show 2 methods. Again, that you could say from the table. When n equal to 5, I need you to show how you get the value from stage number 4. Okay? So you could write something like 2 times 7 plus 2 to the power 3 over 2, which gives me 2 times 9 to the power 3 over 2. So again, since both values match, my rule is verified. Okay? All right, so we have tested, we have verified. Now let's go down to the final bit, which is the justification part, which will give you the maximum point if you've done everything correctly up to now. Okay, all right, so let's just erase all this. And let's see how we can actually come up with a proper justification. Now, at this level, I would say for such an assessment, I think it is important for you to come up with a mathematical proof. Okay, doesn't have to be a formal one, but it should be able to be. It should be done with some algebraic rules that can help you to find the general rule for the area. Now, again, remember when we found the general rule for this question, we were just looking at the pattern, we were looking at sequences, but we did not really talk about how this relate to the diagram, which is basically looking at the rectangle of each of the stage, because generally what you're trying to find is to find the area of each of the stages here. All right, so when it comes to justification, I will recommend you to start looking back at the whole context of the problem. Since the rectangle is being given to you, then we should look at the rectangle and see what we could generate from there. Now, since this is all about area, we know that area is basically the length, right, times the breadth or the width of the rectangle. Now, so we need to go back to the length of the rectangle and see if we can spot a pattern here. Now, the good news is that in the earlier part, we found out that the length of the rectangle, which is AB, all right, we actually found a formula for this, which was 2 square root 2n minus 1. Now, my intention is that if I know that the formula for the length is 2 square root 2n minus 1, all right, because we do know that the width of the rectangle, now in this case, the width is just, the breadth is just 1. In this case, the breadth is like 3. The breadth here is actually 5, okay? So let me just write here. The length of the formula we found in the previous part was, right from the start when we found the formula was 2 square root 2n minus 1. Now the breadth, we know that the formula follows a sequence which is 1, 3, 5, 7. And we know that this formula here is actually just simply 2n minus 1. All right, so what I'll do is if I want to find the area, I can just take 2 square root 2n minus 1 times 2n minus 1. Okay, now, then you might ask, then how does this actually lead to this formula here? Now, a little trick that you need to know. Now, when we have a square root sign, okay, this can be rewritten as 2 square root 2n minus 1 to the power of half. Now, maybe this is something that you may not be aware of, but just a little crash course here. If I were to say 9 to the power of half, all right, this is as good as saying square root of 9. If I say 16 to the power of half, this would be basically square root of 16. So 25 to the power half, this will also could be written as square root of 25. So which means that square root of 2n minus 1 can be rewritten as 2n minus 1 to the power of half. And I'm going to multiply this by 2n minus 1. Now we know that 2n minus 1 can be written as 2n minus 1 to the power of 1. All right, because anything to the power of 1 is just going to give you the original term. Now, and we do know that if I multiply this times this, do you realize that they have the same base? This is the base, and this is the base. They have the same base. So what do we do with the powers when we have the same base? We add the powers, we add the exponents. So what we could do is we simplify this. This will become 2n minus 1, and this will be half plus 1. So that gives me 2n minus 1 to the power of 3 over 2, which looks exactly what we have right from the original general rule, which is this guy. And that's how you justify your general rule. You basically show a mathematical proof by using some rules of the laws of exponents or indices to get to your final answer here. Alright guys, I hope this helps. I know justification or the proving part is always the tricky part, but it's not something that is unachievable. But it's just trying to come down and making sense in the context of the problem by looking at the length and the breadth of the rectangle, because that gives us the area of the rectangle. Alright, so I hope this video helps. If you like it, hit the like button. And if you have any other clarification, just write to me in the comments box, and I will try to make as many videos as possible. Alright, take care guys, and I'll see you soon.